Okay, so back to test 2, part 2, extra credit, question 2. It says figure 5.7 shows a block of mass M resting on a 20-degree slope. The the block has coefficients of frictional static 0.64 and kinetic friction 0.54 with a surface. It is connected via a massless string over a massless pulley to a hanging block of mass 2 kilograms. What is the minimum mass that you will stick that that will stick and not slip? So what helps me out is to write all the formulas that or your free body diagrams, right? So let's begin by in our y direction. So for the 2 kilogram block, we have tension, and pulling down we have weight mg. For the mass, we have for the x block we have our weight pulling it down. We also have mg cosine theta. We also have this tension. We also have pulling it back mg sine of theta. And we have, let's see, chose whether we have massless string over massless pulley to hang out. And we also have our kinetic friction, which is pulling it back. So what helps me is to write out all the formulas. So for our y block, we have the summation of the force of y equals tension minus mg. And for our x, we have hold on, let's see. So we have tension minus mg sine of theta. Oh, and also we have our natural force. Okay. So let's be asking us to get what is the minimum mass mass of m. Okay, so for m, they're asking us to find m. So let's go by f of x is gonna be, so let's write it again. F x equals t minus mg sine squared. So they're asking us to find the mass that would not slip. So we know that our summation of force, which is mass times acceleration, that's going to be 0. So this is going to be 0. So it's going to be 0 equals t minus mg sine theta minus fk. So when we solve for tension, it's going to be mg sine theta plus fk. Now, to find our fk is going to be our n, which is going to be u of s, and since our n of n, but we know n equals mg cosine theta. So our fk is going to be us mg cosine of theta. So our equation is going to be this. Tension equals mg sine plus static mg cosine theta. So when we solve for mg, we could so t equals factor out the mg, you have sine theta plus static cosine theta. And now we're going to divide by g towards g sine theta plus us cosine theta. We're going to move it to this side because we want to isolate the mass. So we have so mass equals tension of gravity sine plus us cosine theta. It's 9.8 sine of 20 degrees plus our value for the U for static, it was 0.64, and cosine of 20. And to find the tension, we know that the block is 2 kilograms. So in the y direction, tension in the y, we know that a tension is 2 kilograms, and we multiply that times gravity, and we end up with 2 times 9.8, 19.6. 19.6. So that's going to be our tension, which is going to go here. And then when we solve, we end up with, I'm going to do step by step, 19.6, 9.8, sine of 20.342 plus 0.64 times the cosine of 20, we get 0.601, 19.6, 9.8, and we add these two values together, plus 6.01, 943, we go back, 0.943, so we got 19.6. 19.6 divided by 9.24, we end up with 2.12 kilograms, or 2.1 kilograms. So this 2.1 is our weight for the mass in the M, so on the block, on the small block, or the block on the 20-degree angle. So since our value is 2.1, the answer to this question is going to be C.